Imagine standing outside on a clear night. You look up. You see stars, maybe a few thousand of them with your naked eye, and the Milky Way stretches across the sky like a river of light. It's beautiful. It's vast. It feels infinite. Now I need you to understand something. That entire river of light, every single star you've ever seen, every star that's ever inspired a poem, a painting, a prayer, all of it, our entire galaxy with its 400 billion stars is a footnote. A grain of sand in a desert we haven't even begun to map. Because somewhere out there, a billion light years from where you're sitting right now, there exists a galaxy so monstrous, so incomprehensibly enormous, that if you replaced our Milky Way with it, it would swallow our nearest 20 neighboring galaxies, whole, without a trace. So here's the question that should keep you up tonight. If something that enormous exists, what else are we missing? This is not science fiction. This is not speculation. This is a real structure, confirmed, studied, and still not fully understood, sitting at the heart of one of the most massive galaxy clusters ever observed. Its name is IC 1101, and it is, by nearly every measurement we have, the largest known galaxy in the observable universe. 6 million light-years across, 100 trillion stars. A structure so large that light itself, traveling at 186,000 miles per second, would take 6 million years just to cross from one edge to the other. For context, modern humans have only existed for about 300,000 years. We would have to evolve, go extinct, and evolve again 20 times over, before a beam of light finished its journey across this single galaxy. Tonight, we're going there. We're going to explore what IC 1101 is, how it got so impossibly large, what lives at its center, and what its very existence tells us about the universe and about us. Buckle up. The story of IC 1101 begins not with a dramatic eureka moment, but with a catalog. The year is 1790. A British astronomer named William Herschel, the same man who discovered Uranus, is systematically sweeping the night sky from his garden in Slough, England, night after night, season after season. He's cataloging faint smudges of light that don't quite fit anywhere. Things that aren't stars. Things that aren't planets. Things that at the time, no one had a word for. On one of those nights, he recorded a faint glow in the constellation Virgo. He didn't know what it was. He filed it away. Entry IC 1101. For over a century, that smudge sat in a catalog, ignored, unremarkable, one entry among thousands. It wasn't until the 20th century, when Edwin Hubble revolutionized our understanding of the cosmos, that astronomers began to realize those smudges weren't clouds of gas inside our galaxy. They were entire galaxies, other Milky Ways, billions of them, each containing billions of stars. And IC 1101, that unremarkable smudge in Herschel's notebook, turned out to be the biggest one of all. The true scale of IC 1101 wasn't confirmed until the late 20th century, when modern telescopes, including the Hubble Space Telescope, began mapping its full extent. What they found stunned the astronomical community, because IC 1101 doesn't just look large in a photograph. It is large. Verifiably, measurably, jaw-droppingly large. Our Milky Way, approximately 100,000 light-years in diameter. IC 1101, approximately 6 million light-years in diameter. That's not twice as big. That's not 10 times as big. That's 60 times larger. One scientist, upon seeing early size estimates, reportedly set down his coffee, stared at the data, and said, and I'm paraphrasing here, "That can't be right." Run it again. They ran it again. It was right. What kind of galaxy is this? Before we go further, let's establish what kind of galaxy we're dealing with. Because IC 1101 isn't a spiral galaxy like the Milky Way with those elegant arms curving outward like a celestial pinwheel. IC 1101 is an elliptical galaxy. Specifically, a supergiant elliptical galaxy. Think of a spiral galaxy as a busy city, traffic flowing in organized lanes, new construction happening in the suburbs, young hot neighborhoods lit up bright blue. An elliptical galaxy is more like an ancient empire, massive, dense, ordered in its own way, but old. Its star-forming days are largely behind it. Most of IC 1101 stars are ancient, billions of years old, glowing in dim shades of orange and red. There's not much new star formation happening here. This galaxy has lived fast, and it has grown spectacularly large. The numbers and why they break your brain. Let's talk numbers. Because the numbers are where things get genuinely disorienting. 100 trillion stars. Write that out. 100 trillion. Our Milky Way has somewhere between 200 and 400 billion stars, and that already feels incomprehensible. IC 1101 has roughly 500 times more. If you tried to count IC 1101 stars at 1 per second, without stopping, without sleeping, without eating, you would finish in approximately 3.2 million years. You'd need to start counting before the first humans ever walked upright. But here's what's really wild. Those 100 trillion stars? Most of them are packed into a region of space that, from Earth, appears as a single smudgy dot of light. The universe is very, very good at hiding things. Where is it, and how far away? IC 1101 sits approximately 1.07 billion light-years from Earth in the constellation Virgo. That means the light we're seeing from it right now left that galaxy over 1 billion years ago. When that light began its journey toward us, complex animal life on Earth was just beginning to emerge. The first fish were swimming in ancient seas. The first land plants hadn't yet existed. We're not looking at IC 1101 as it is. We're looking at it as it was over 1 billion years ago. Whatever it looks like today, we won't know for 1 billion years. That's not a figure of speech. That's a literal physical fact. The black hole at the center. Now let's talk about what lives at the center of IC 1101. Because if the galaxy itself is terrifying in scale, the engine driving it is in another category entirely. At the core of IC 1101 sits one of the most massive black holes ever detected. Estimates suggest this black hole could contain the mass of 40 billion suns. For comparison, the black hole at the center of our Milky Way, Sagittarius A*, contains about 4 million solar masses. IC 1101's central black hole is roughly 10,000 times more massive. 10,000 times. If Sagittarius A* is a campfire, the black hole in IC 1101 is the surface of the Sun. And this black hole has almost certainly played a central role in shaping the entire galaxy around it, directing traffic, suppressing star formation, acting in a very real sense as the galactic engine at the heart of everything. How did it get so big? The cosmic appetite. IC 1101 didn't start out this size. Nothing in the universe does. It grew, and it grew the way galaxies grow when they reach a certain scale by eating other galaxies. This process is called galactic cannibalism. And yes, astronomers actually call it that. Apparently, physicists enjoy dramatic terminology. When a large galaxy sits at the gravitational center of a massive galaxy cluster, as IC 1101 does, at the heart of the Abell 2029 cluster, it begins to pull neighboring galaxies toward it. These smaller galaxies fall inward. They get stretched by tidal forces. Their stars are stripped away and absorbed into the larger galaxy's halo. Over billions of years, IC 1101 has consumed potentially dozens of galaxies, each meal making it bigger, each collision giving it more mass, more reach, more gravitational pull to attract the next victim. It is, in every measurable sense, the apex predator of its cosmic neighborhood. What if you actually went there? Let's say, hypothetically, you stepped into a spacecraft tomorrow, a magical one that could travel at the speed of light. You set your coordinates for IC 1101 and hit go. Your journey would take 1.07 billion years. Not 1.07 billion years in stasis while the universe ages outside you, though that would happen too. Just 1.07 billion years of traveling. By the time you arrived, the Sun would be nearly halfway through its remaining lifespan. Earth, assuming it still exists, would be unrecognizable. But let's say you get there. You arrive at the outskirts of IC 1101. Here's what you'd find. The sky, in every direction, would be filled with stars. Not a few thousand like our night sky. Not the 100,000 you can observe with a good backyard telescope. Millions of visible stars. In every direction, constantly. The night sky inside IC 1101, particularly near its core, might never actually go dark. The star density near its center is so extreme that the ambient starlight could create perpetual twilight. You'd look for the galactic center, and you'd find it, a glowing, faintly pulsing core that dominates the entire sky. A 40 billion solar mass black hole hidden inside a compressed ball of the oldest, densest stars in existence. And here's the terrifying part. You would have absolutely no way of knowing what happens next, because we don't fully understand what IC 1101 is still becoming. For all of its size, IC 1101 still presents science with some genuinely uncomfortable questions. The first, is it still growing? IC 1101 sits at the center of a galaxy cluster containing hundreds of galaxies. Many of those galaxies are on long, slow inward trajectories. Some astronomers believe IC 1101 is still actively accreting, still slowly consuming neighboring galaxies even as we observe it. If that's true, the structure we're seeing is not the final form. It's a work in progress. The second, what is happening with its star formation? One of the great puzzles of supergiant elliptical galaxies is that they appear to have largely stopped forming new stars. They have the gas. They have the mass. But the star formation has slowed to a trickle compared to their past. Scientists suspect the central supermassive black hole is the culprit, periodically unleashing jets of energy so powerful they heat the surrounding gas, preventing it from collapsing into new stars. The galaxy's engine, in other words, may also be the galaxy's brakes. The third, will it keep growing forever? Here's a theory that some cosmologists find genuinely unsettling. In the very far future, we're talking hundreds of billions of years from now, as the universe continues to expand and galaxies drift farther apart, the largest gravitational structures may begin to merge into singular, massive entities. IC 1101 could be a preview, a prototype of what the universe eventually produces when given enough time, one enormous galaxy, containing most of the available matter in its local universe, floating alone in an increasingly empty void. A galaxy that ate everything, and then had nothing left to eat. As for future observations, the James Webb Space Telescope has already begun expanding our ability to study distant, massive galaxies with unprecedented clarity. Future missions and next-generation observatories may finally let us directly measure IC 1101's current star formation rate, map the full extent of its dark matter halo, and get a cleaner look at the environment around its central black hole. The answers are coming. They're just traveling at the speed of light. There's a moment in every honest conversation about the cosmos where the science stops being just science, and it becomes something else, something personal. When you absorb the reality of IC 1101, a galaxy 60 times larger than ours, a trillion stars older than most of what we know, a structure that has existed and evolved for billions of years before humans had fire, the natural human response is to feel small. And that's okay. In fact, that feeling might be one of the most important feelings a person can have. Because here's what that smallness tells you. The universe was not built to our scale, or our timeline, or our comfort. And yet, we found it. We, a species that for most of its existence couldn't explain thunder, built instruments precise enough to measure a galaxy a billion light years away. We launched a telescope into orbit and pointed it at the darkest, emptiest looking patch of sky we could find, the Hubble Deep Field, and discovered that empty patch contained 10,000 galaxies. We are, by any cosmic measure, extraordinarily small. And we are, by any measure I know how to calculate, extraordinarily capable. The American space program, from the Apollo astronauts who first left this planet to the engineers behind Webb, Hubble, and every mission in between, has always been driven by the same basic instinct. We want to know what's out there. Not because it's always practical, not because it's always profitable, but because something in us refuses to accept a horizon as a boundary. IC 1101 is the ultimate horizon. A structure so vast it challenges the very limits of our conceptual vocabulary. And the fact that we know it exists, that a smudge in Herschel's notebook became a confirmed, mapped, studied behemoth, is proof of something remarkable. We are small, but we are paying attention. And in this universe, attention matters. We started tonight with a question. If something as enormous as IC 1101 exists, if a galaxy so massive it swallows its neighbors whole, so vast that light takes 6 million years to cross it, so ancient it began forming before Earth was anything more than a swirling cloud of debris, if that exists, what else are we missing? The answer, the deeply, uncomfortably, wonderfully true answer, is almost certainly a lot. IC 1101 is the largest galaxy we've found. In the observable universe, the portion of space whose light has had time to reach us. But the observable universe is not the whole universe. Not even close. The full universe, stretching beyond what any telescope can ever reach. Maybe thousands, millions, or infinitely larger than what we can see. There may be structures out there that make IC 1101 look like a grain of sand. There may be galaxies, clusters, and cosmic architectures that operate by rules we haven't discovered yet. We don't know. And that is not a failure of science. That is the most exciting sentence in science. We don't know yet. IC 1101 is a mirror, not a literal one. Trust me, the commute would be unreasonable, but a cosmic mirror. One that shows us what the universe is capable of building when given enough time, enough gravity, and enough smaller things to consume. And it raises the question we'll probably be asking for as long as our species exists. In a universe this vast, this old, this incomprehensibly large, is any of this here just for physics? Or is there something someone somewhere in those 100 trillion stars looking back? We don't know, but we're looking. And we're not going to stop. If IC 1101 made you feel something tonight, whether that's wonder, or terror, or that specific brand of existential dizzy that only the cosmos can produce, then we did what we came to do. This is what space does. It doesn't just expand your knowledge, it expands something harder to name. If you want more of that feeling, subscribe. We're just getting started, and where we're going next makes IC 1101 look like a warm-up. Next time, we're going somewhere that contains almost nothing. No galaxies, no stars, no black holes. A place called the Void, and why that emptiness might be the most important and terrifying thing in the entire universe. See you there.